So HTTP3 and QUIC. So I'm Daniel, as mentioned. I work on curl. I started it 22 years ago, been doing a lot of HTTP client-side programming since then, all the protocols, all the HTTP versions. I work for Wolf SSL these days. I do curl support all day long, full-time curl in my days. I work within the organization IETF as well, which is the organization behind a lot of internet protocols, including all the HTTP versions, and now HTTP3 and QUIC, which I'm going to talk to you about today. So I'm going to try to go through this little agenda here. First, a little brief journey through HTTP 1, 2, 3, and in particular why 1 and 2, some of the problems, and why we are looking to 3 now, and how 3 is, HTTP3 is a protocol built on QUIC, which is a new transport protocol, how it works, a little bit about HTTP3 on top of QUIC, some of the challenges with deploying and getting into HTTP3 today, and HTTP3 is coming soon. So as mentioned, I'm going to try to do this fairly quick to make some room for questions in the end. Otherwise, I'll be in the GOTOpia Slack at least today. And I'm also available on Twitter if you find yourself with questions afterwards. So this is HTTP one-time photo, basically. HTTP 1 came 1997, the first version. It existed before that, the 1.1 version actually. It existed before that, but HTTP 2 came in 2015, and we're already now working on the HTTP 3 version. HTTP is, of course, the protocol that looks like this. If you send it from a client side, you send a request and you get headers, or you send headers as well in the request, and you get a response back, which is a response code, and headers back and a body, blah, blah, blah. You all know that. It looks like that, and has looked like that for a long time. So HTTP is done over TCP. TCP is basically this chain. I like to visualize the protocol as individual links put together with some code, basically. So it's transport done over IP. It sets up a connection. It's a reliable connection. You get the bytes in order. If you lose a packet, it'll be retransmitted. And it's a clear text. Everyone can read it online on the network. And there's a ping-pong, ping, three-way handshake. Okay, that's TCP. The first RFC for TCP came 1981, so the protocol is approaching 40 years now. These days, we also talk about HTTPS a lot, right? Because HTTPS is really what's driving the internet now. We're moving the clear text version HTTP and going HTTPS. And here's a graph from data from Firefox, but the trend is like this, so that's the takeaway here. More and more HTTPS going forward. So we're talking about a world where we add TLS on top of TCP. And TLS is then the added transport layer security on top of TCP. And additional handshake, privacy and security. Privacy in that we know that nobody can eavesdrop on your traffic, and nobody can interfere with the traffic or change data on path or in transit. And we know that we're talking to the right server in the other end. So both privacy and security provided by TLS. So this is how a traditional classic HTTPS stack looks like. We have IP, and we do TCP over that, and we have TLS, and then we do HTTP on that. That's the HTTPS, done the way we've done it for many years. IP, TCP, TLS, HTTP. So HTTP done over TCP started out then with HTTP 1, or 1.1, that came 1997, in which people and all of us realize that it's really difficult to do unless, do, for example, a good browser without doing a lot of parallel TCP connections, because HTTP 1 is very serial. So typically browsers start up 6 connections per host name, and they can do many host names. So by doing a lot of parallel TCP connections, you can do more things simultaneously, of course, but it becomes very ineffective TCP use. So basically, you never get your TCP connections up to speed. It's a huge problem. And you get a HTTP head of line blocking problem, which means that you get a finite set of number of connections. And as a client, a browser, when you want to send a new request, you have to put that request on one of the existing connections. But which of the connections should you use? It's a difficult problem, and you can easily end up with your new request waiting for the connection because the request ahead of you is slow or bad in some way. Like lines in the supermarket. Which lines which line is yours? Which are you going to bet on when you want to get through to the cashier? There, of course, were a number of workarounds introduced that we've done, sharding and spriting and putting all JavaScripts into one file. We put images into style sheets. We've done a lot of fun things to work around those issues. Many of them were put into the protocol HTTP2, which shipped in 2015. And now we've gone into a world where we try to do a single connection per host instead of 6, 12, 18, 49 connections per host. And now we're doing a single connection per host, and we do many parallel streams instead over that single connection, which then brought us into another head of line blocking problem, namely the TCP one. So now if we do 100 streams over a single TCP connection and we drop a single packet, we have to let all those streams wait for that single packet to get retransmitted, the TCP head of line blocking problem. And we're also working in a world which gradually over time has grown ossified. The ossification problem in the world is basically like this. We have a world full of boxes, servers and things like routers, gateways, firewalls, load balancers, and network address translators everywhere. And they run software to handle this data, and they're running software that handle data and protocols the way the protocols worked when these boxes were deployed, and they are not upgraded very often, which usually ends up the result and makes that the protocols need to keep working as they worked at the time when these boxes were deployed. Basically like this. Internet looked like this. That's the server, that's me. We talk through a lot of boxes to reach the server. Those all green, the green ones here, they're all middle boxes. They all know, within air quotes, how the protocols work, and they know when things isn't the way they think it should be and throw stuff away or damage them. Like, for example, middle boxes like that, they prevent, for example, good use of HTTP2 in clear text across the internet, because if you speak HTTP on port 80, TCP port 80, a lot of middle boxes, they know that is actually HTTP1, and they will fix that protocol for you if you try to speak another protocol. So they will effectively break HTTP2 if you do that. Or for example, we worked hard to improve TCP and introduce TFO, TCP fast open, to do faster TCP opens. Well, actually send data earlier in a TCP connection lifetime. But it turns out really hard to deploy too, because of these middle boxes that know how the little bits in the TCP headers should look like, so they throw away, making the net result being that TCP fast open is very often a very TCP slow open. So nobody is enabling that by default today. Similarly, we can't introduce new replacements for TCP or UDP because a lot of these boxes, they know that those are the only protocols that exist, so they throw away other stuff, and they can't do NAT for them and so on. In HTTP layer, we introduced a compression algorithm to effectively make better gzip. This came several years ago, but in same manner here. All the browsers, they're only using Brotli now if you're doing HTTPS transfers, because otherwise a lot of middle boxes will fix your gzip when it isn't gzip and ruin the traffic. So it really, really hampers future innovations and make things hard to change and improve over time unless we do things encrypted. So we need to improve transports and HTTP in spite of this ossification that everything knows how things used to work back in the days. And this is what QUIC is trying to do. QUIC is an effort powered by a lot of big companies and names. As you can see, this is just a bunch of fancy logos from company representatives that are involved in this effort. So a lot of the browsers, big data providers, CDNs, they're all involved and making sure that this becomes a proper protocol. So this is a new transport protocol, and it's built on experiences with Google's QUIC, which confusingly also is called QUIC, but it's not the same protocol anymore. So Google actually deployed this 7 years ago by now. So they proved that it worked because they have a very widely used client and they have widely used web services. So they proved that it really works and it really improves performance enough to make this an interesting path to go forward. They took it to the IETF in 2015, the same year HTTP2s came out, and it became a working group the year after. And I want to emphasize then that that was the Google QUIC. They took it to the IETF, and after IETF, sort of when they have been worked on it within the IETF, or we, I should maybe say, it has turned out into a different protocol. So some of the fundamental ideas from the beginning may possibly remain. Well, I think that we can say that they remain. It's still done over UDP, but it's a completely different one now over the wire and with a lot of different concepts. So when doing a new transport protocol, you can fix things, right? It's like all of those people that have worked with TCP for 40 years and they have a lot of, the wish list. Why not fix this when we do a new thing? We can fix the TCP header blind blocking problem. I'll get back to how. And we can do faster handshakes like zero RTT handshakes, send data earlier in connections like that fast open I mentioned. We can do connections that aren't tied to your network interface so that the they can transition to new network paths without having to tear them down and set up a new one as you do for TCP. And you can do more encryption, and with QUIC it is always encrypted. There's no clear text version of the protocol. So the hope here is that by doing this we can enable future development of this protocol because it's encrypted, so nobody in between you and the server, you and the endpoint, the client and the server, can actually see the traffic or interfere with it or draw conclusions that it look the same in the future. So this is built on top of UDP. They remain, so TCP and UDP remain the ones, right? The protocols we will go into the future with. But this is a new protocol built basically using UDP as if it was IP. So it's a reliable transport protocol. It's really, yes, it's UDP, but it's reliable because it's a transport implemented just over UDP. So it has to be, it's a new TCP TLS-like protocol using UDP. And it has streams then within connections, and they are independent, meaning that if like in the good old days, or like today, and when we set up a connection with TCP, and if we would use several streams, like in HTTP2, we would have a green stream and a red stream here. But if we would lose a packet, maybe the red stream here would lose a packet, the green stream can't continue on because there's a single connection. We have to retransmit that lost packet, and then both streams can continue flowing. While in the QUIC land, the streams are independent. So if you have a yellow stream and a blue stream, like this image here, and if you lose a packet from the yellow stream, and that packet only affects the yellow stream, the blue stream can still fly past the yellow stream while the yellow stream is waiting for that packet to get retransmitted. So even if you have a huge number of streams over the same connection, the other streams are not affected by lost packets, only the streams that actually are within that lost packet. And QUIC is then just the transport protocol. You then do application protocols on top of QUIC. And all those protocols then, of course, get streams for free, and it could be any protocol. HTTP is going to be the first. There will be more coming after that. HTTP 3 is that first protocol done on top of QUIC. So HTTP 3 is the same HTTP that we've done before. It has a request, you send method and path, headers, possibly a body when you do like a post or a put, and you get a response back, response code, headers, and a body. This is the same HTTP we've seen before. We know it. It's going to remain like this forever, right? It's the same thing, but different. In HTTP 1, we sent ASCII headers basically over TCP. In HTTP 2, we changed it into binary headers, and it became multiplexed over TCP. Now in HTTP 3, we run it binary over the multiplexed QUIC. So we don't do the multiplexing anymore in HTTP, but we do it underneath in the QUIC layer. So to compare the old stack versus the new stack, it looks like this, right? We're still on IP, but we used to do it TCP, TLS, both HTTP1 and HTTP2 they do it this way. But now instead, we go over UDP and we put QUIC on that. and QUIC, always encrypted using TLS. And we have HTTP3 on top of QUIC, the application protocol on top of the transport protocols. And the streams have now been moved from the HTTP layer down into the transport layer. Not that it matters too much, but it makes it possible to do other application protocols with streams. So a different stack here. Maybe the biggest point and the biggest thing to remember going forward is that it's going the UDP route instead of the TCP one, and everything on top of that is new. And HTTP layer-wise, HTTP3 is similar to HTTP2 in feature-wise. It's pretty much the same way, but the underlying transport protocol is very different, which gives it different characteristics. So we changed the transport. We still have streams. We cannot do any clear text version anymore. We have independent streams now, so streams actually can fly past another stream if you lose packets. We do header compression, still a different one, but we can still do server push, even if server push might not actually be used very much because the browsers are discussing to drop it. But anyway, and we can do early data, in theory better than before because it's in the protocol from the beginning now. And we can do much faster handshakes, so we can actually do 0 RTT, no round trips at all to do a new handshake. And the previous version needed at least 3, sometimes, well, usually more than 3, maybe 5 or 7 to get the TLS up as well. And the prioritization is changed a lot. It's actually not even present in HTTP3. It's going to be added on top of it later, and possibly the HTTP2 is it's likely going to be backported into the HTTP2 in the future. HTTP3 is faster than any other HTTP protocol, thanks to QUIC, really. We have faster handshakes. We have an improved loss recovery in the transport protocol. We can do early data that works, so we can actually send the HTTP requests really early in the connection's lifetime. And the independent streams make the connections work much better, especially in lossy, bad network situations. But exactly how much faster is really a challenge to tell. Google says it's significantly faster, and Facebook says it generally outperforms the others. I think we still need to get the numbers in to tell exactly how fast it is going to be in different situations. So we're going to live with HTTPS://URLs everywhere for a long time. And that means those URLs, they imply TCP port 80, right? So that's how do we switch into a UDP world with HTTP3. So we have this header. It's an alternate service response header. The server responds to the client, says, I'm also available over here. My HTTP3 service is here. Connect there instead. And so clients will cache that information and then use that HTTP3 server for that period of time going forward. And I'm pretty sure, and it'll happen, that clients, browsers will also just raise connections. Try both, or try HTTP2 and HTTP3 at the same time. And the clients will end up in situations when they are going to need that anyway. So I'm pretty sure we will see that. Just try both. And it'll be pretty safe because QUIC connections, they're always encrypted. So they have to verify the certificate anyway. So you can be sure that it won't connect to the wrong one by mistake. There's also a new work in progress to add a new RR, that's a record in the DNS database, so that you can actually provide that old service information already in the DNS, so that the client knows that already when it has resolved the hostname. There are a lot of challenges to deploy HTTP3 today. It uses more CPU, possibly. Oh, sorry, I'm skipping ahead in my mind. A lot of connections are failing because organizations and companies are blocking UDP and UDP traffic, because UDP traffic at this rate has traditionally been used mostly for the distributed DOS attacks, and they're not anymore. Well, they're used for that as well, but they're used for this too. So clients need to do fallback algorithms, like browsers need to be able to, seamlessly switch back or fall back to HTTP2 or HTTP1 instead, which also then makes it easier for organizations to keep these blocks, because clients will have to deal with them anyway. And for servers, the traffic looks like a DDoS attack because it's always encrypted. It uses more CPU in the servers. It traditionally used a lot more, up to 2-3 times the CPU, but it's getting better, especially if you're using the latest and greatest patches to the kernels. But this is because we have very unoptimized UDP stacks in Linux and elsewhere, possibly because we haven't really tried this before, high-speed UDP traffic through the internet. And we have a really non-ideal UDP IPs to send data back and forth. And we don't have hardware offload properly for the encryption yet. And we have a really ugly TLS situation in that TLS was done for TCP, so we sent records inside with messages inside, and now QUIC is doing it differently. I just wanted to visualize it like this. So TCP sends TLS records with messages inside. So here are 2 records with messages inside. Easy peasy, but there are sort of frames around the messages. But when doing TLS, there's no record around the messages. They're just plain messages. But no TLS library had access or gave access to the messages before. So you couldn't actually do this with the TLS library. So the TLS libraries have worked on implementing this support ever since the QUIC effort started. And in the TLS world, OpenSSL is a major factor, the leading TLS library used by a lot of clients and servers, a huge portion, a majority. And they postponed their QUIC work to happen after 3.0. And 3.0 itself has been delayed significantly by many months. And they have an alpha out, but still it's not going to happen until sometime early mid-2021. So the QUIC work from OpenSSL is seriously delaying. It's seriously delayed. So using a released or actual OpenSSL version is hard. So you have to work with development versions or patches, or you use another SSL or TLS library. Also, all these implementations are done in user land. So all the QUIC stacks are user land, and there's no standard QUIC API. So you have to, pretty much get married to one of the libraries and stick to that when you build your application. And it's not going to be that easy to switch between the different libraries if you run into problems or if one goes bad. Sometimes people ask me if I think they will be moved into kernels, these stacks, but I don't think that will happen soon. Of course, you can run your own experiments and you can build your own kernels to do that. But into an official public release kernel, I think it's very, very far away because it's a huge stack and TLS and everything. So how to do this, or how to understand how this works, you also need tooling, right? So you need to understand the TCP numbers and windowing segments and everything that you've learned and used, sort of understood for a long time. It's all gone now. Now you need to get into this new world of everything encrypted. And so you need tools that understand the encryption and can understand the new protocol. So hooray for Wireshark, they're on track of everything. So the latest Wireshark can decrypt and understand and analyze the latest QUIC and HTTP3. And of course, there's now also a new logging format and visualization tool to actually that a lot of the server implementers and client implementers are supporting, that are logging details for the QUIC and HTTP3 layers to help you understand what's going on. So when will this happen? The ship date, yes. I've done this presentation many times through the years about HTTP3 and QUIC, and I've sort of always added a year to the number here, but it should ideally, hopefully, be done by early 2021. I don't know exactly when early, what it means, but yeah, we'll see. It's really, really final stages in the working group in the IETF, so there shouldn't be many changes in there. Mostly just wording, polishing, getting sure that everything is crystal clear. There are many implementations of QUIC and HTTP3 already. Done by all these companies I mentioned before and some others. They exist in a large variety of different programming languages, and many of them are open source. You can join in and play with them already now. They've done monthly interrupts for years now, so most of them work very good with each other and work with the protocol specs. You can try it out with a lot of different clients and servers. You can do it with curl, all the latest browsers, some of the servers, and there's previews and patches for other servers. There are TLS libraries that support the necessary quick details, like boring SSL and GNU TLS might be the ones, the biggest ones that are on track with this stuff. And of course, Wireshark, as I mentioned. There are some projects that aren't really there, so we have to wait for them. There's no Apache HTTPD, there's no IIS, and as I mentioned, OpenSSL is behind. There's a patch, there's a pull request that you can patch your own OpenSSL and try it out, and that makes the OpenSSL version work similar to the API used in boring SSL. So you can already now switch on HTTP3 with your browsers. If you go with Chrome or Edge, you can just use the proper command line switches, even in the stable version. If you go with the Firefox, you go with the nightly, and you can just edit this in the config. And with Safari, you can go with I think it's the latest one, you can actually enable experimental features and enable HTTP3. So all of them can use it. And you can already now go to these sites, Facebook, Instagram, Google, YouTube, and Cloudflare. Well, and you can also enable your own, if you run Cloudflare CDN on your site, you can enable that for your own sites. And then you can actually use HTTP3 today, the live IETF version, and see how it works. I have this URL at the bottom of the screen here that has a list of different implementations and their test servers that you can play around with if you want to dig deeper. And of course, as I mentioned, I work with curl. You can do HTTP3 in curl. It works. It's experimental. You have to build it yourself. It's not there in any shipped binary packages. Alt service support is there, so you can use the alt service approach. And we have two different backends, and you can pick either one when you build curl. And I don't have any fallback in curl yet. You know, if HTTP3 doesn't work, fall back to the other ones because it's a little bit tricky. So I'm still behind on that. You should try it out, and if you do try it out, curl works like this. If you'd use this option, this -- HTTP3 makes it try HTTP3 immediately without alt service, and then you get the HTTP3 back just the way it looks like with any other protocol version. Easy peasy. My prediction for the future is that HTTP3 will take longer time to happen because of all these challenges and the TLS issues, and possibly also because the benefit is not that huge to everyone, not as big as HTTP2 was. So I think it'll grow slower until it sort of gets that huge adoption. So because of the challenges and possibly smaller gains, some people will just stick to HTTP2, especially if you're a smaller player. The bigger ones, I mean, the Googles and the Facebooks, they will be on HTTP3. They're already there. So QUIC is here for the long term. It's a new transport protocol it's going to be the TCP replacement for a lot of stuff going forward. So I'm convinced that we will see a lot of more QUIC going forward. And within QUIC itself, there's going to be a lot of new improvements and changes. There's a fierce discussion about multipath, for example, setting up multiple paths through the network, like multipath TCP, but for QUIC then. So people, as soon as QUIC version 1 is shipped, people are going to jump on these other things, like doing unreliable streams, partial reliability, and of course, a lot of more application protocols to be done over the QUIC transport protocol. So as HTTP is the application, the QUIC that transports more application protocols, perhaps DNS, perhaps, well, a lot of other things that could be done. So some takeaways from what I've said today is that HTTP3 is coming. Early 2021, maybe. It's always going to be encrypted thanks to it being over QUIC. The features in HTTP3 are similar to HTTP2, but the transport is completely different. And the transport is done over UDP, all new and different. There are challenges. I mentioned a few of them. There are going to be more, I am sure. And as I said, early 2021, maybe. I really think so. But I'm always the optimist, maybe not always the realist. So we'll see. We just have to, we can at least try it out already now, as I mentioned, with the browsers and the servers. I wrote most of these details in a little book. You can go find it, called HTTP3 Explained. Yes, thank you.